So determining sample size for t-test. So we have various types of t-tests. We have the independent sample t-test and we have the paired sample t-test. So in the independent, we have two separate groups, while the paired sample t-test is the same subject that were measured twice. And we also have the one sample t-test whereby we compare sample mean to a known value. For any independent sample t-test, we are comparing a treatment group with the control group. So we usually calculate our D using the coherence D. So that is the mean of the first group minus the mean of the second group divided by the standard deviation. On the significance level is usually 0.05, the power is 0.8, and this type is a two sample. Or usually two-sided. So these are the key parameters in R that are going to provide. So the number per group is needed, that is the N. So this is it. You can see the post standard, the formula earlier on I showed you the mean of the first group minus the mean of the second group divided by post standard deviation will give you the coherence D, which is your effect size. Now, your effect size now, small effect is 0.2, subtle difference, 0.5 is a medium effect, 0.8 is a large effect. So if the treatment mean is equals to 120, then control mean is 110, then standard deviation is 20. For the two-sided, which is usually the default, with the mu1 is not equals to mu2, which means that is the null hypothesis, the means are different. So we have no prediction or direction. It is more conservative and it requires a larger sample size. But for one-sided, mu1 can be greater than mu2 or less than mu2. And usually have a stronger prediction because we know we are one-sided, we are sure where we are going now. It requires a smaller sample size and it is justified when direction is certain. So also in pair sample t-test, before after measurements match pairs, we calculate D based on difference scores, both of the difference between the first measurement and second measurement. This particular difference is divided by the standard, the mean of the difference will not divided by the standard deviation of the differences. And usually more powerful but needs fewer participants. So advantage is control for individual variability, reducing error variance. So one sample t-test, we compare sample mean to known population value. So is the average IQ of medical students different from 100? So this is an example of a one sample t-test. In one sample t-test, the key parameter usually the sample mean minus the population mean divided by the standard deviation, and the power analysis gives the total N that is needed. So for a two sample t-test at alpha 0.05 and power 0.8, at effect size 0.2, you have 393 per group. At 0.3, 175 per group. At 0.5, 64 per group. At 0.8, 26 per group. So this, you can see the N reduces as the effect size increases. So small effects usually require larger samples. So practical considerations, we have what we call attrition, maybe loss to follow-up or dropouts. So one need to add 10 to 20% to account for dropouts. So if you have 64, you need to recruit 20% more of that particular number. So your total recruit is going to be 77. That you are going to be accounting for dropout from the study or attrition. So on equal group sizes, so power calculations can assume equal N. On equal groups actually reduce power and use harmonic mean if the groups differ. So what are practical considerations for t-test? So each additional comparison increases the type 1 error and may need Bonferroni correction, and also reduce power increases needed sample sizes. So anytime you have reduced power, you need to increase your sample size.